Lesson 5.4 goes into multiplying fractions. Now, usually multiplying fractions is an easier process than adding or subtracting because we don't have to worry about common denominators. However, we do need to remember you can do some simplifying first. If you simplify first, you will be able to rename into simplest form much easier at the end. So I'll change to a different color here. We have 7/10 times a negative 4/21. So first thing I'm going to do is I'm going to look at the numerators and the denominators and see if there's any way I can do some reducing. I have 7 and I have 21. They have a common factor being 7. So 7 can go into 7 one time, and 7 can go into 21 3 times. I don't know if that blue is very easily read, so I'm going to go ahead and change to white. Now, the next numerator and denominator I see is 4 and 10. Both of those are even numbers. 4 will not go into 10 evenly, but 2 is a common factor. So I'm going to go ahead and I'm going to rename my 4. 2 goes into 4 2 times, and 2 goes into 10 5 times. So now let's make that a little bit easier to read. This new fraction here is 1/5, and I'm going to multiply it by, it's a negative, and I have 2 as my numerator and 3 as my denominator. Now, multiplying is just going to go across with the numerators just like it did in addition and subtraction. So 1 times a negative 2 gives me negative 2, and 5 times 3 gives me 15. And then the same process applies. Can I reduce or simplify that? And I cannot. So negative 2/15 is going to be my final answer. Now, if I didn't reduce, I would have had negative 28 over 210. That's a little bit harder to find factors that go into both of those because our numbers are larger. If we can make them smaller to begin with, we'll recognize the simplifying at the end. Moving on, here we go ahead with a mixed number. Whenever we see mixed numbers, we want to change those into improper fractions. So 4 times 4 is 16. And then 16 plus 3 is going to give me 19. So I have 19/4. Make that one better. 19/4. And I'm going to multiply that by 63. Now 63 is not in fraction form either. So I'm going to change it to 63 over 1. Now look at my first numerator, 19. 19 is a prime number. It doesn't have any factors that go into it, and I already have a 1 as the opposite denominator. However, I can do something with my 4 and 63? I can't because neither one of those have a common factor either. So I'm going to go ahead and I'm going to use my calculator and I'm going to do 19 times 63. And I end up with 1,197. That is all going to be over 4. Now I need to change this into a mixed number because it's an improper fraction. So I'm going to plug into my calculator 1,197 divided by 4. I'm going to get the big number of 299 and some decimals. I'm going to clear it, do 299 times 4. When I do that, I'm going to get 1,196. So that means I need one more to get to the 97 I started with. So my answer is 299 1/4. Moving along, this time I'm going to have 2 mixed numbers. So I'm going to change them both to impropers. 2 times 4 is 8 plus 11. I have a negative 11/4. 3 times 5 is 15 plus 1 will give me 16, and I keep that denominator as fifths. Negative 11 and 5, those do not share a common factor, so I cannot do any reducing. However, I get lucky here. 4 and 16 I can. 4 goes into 4 one time, 4 goes into 16 4 times. So now I can go ahead and multiply across. Negative 11 times 4 is a negative 44. 1 times 5 is 5. Improper fraction, so I need to simplify to a mixed number. 5 goes into 44 8 times. 8 times 5 is 40. So that means I have 4 remaining. Don't forget your negative. I have 4 remaining, and they're in fifths. My answer is negative 8 4/5. So you knew what was coming. I'm going to throw in some variables. So I'm going to do the same process I did before, though. This time I have 2 fractions already, so I'm going to see if there's any simplifying. I can't do any simplifying with m and 5 because they are not like terms. However, I can look at my denominator 3 and my numerator negative 12, and I can reduce those. 3 goes into 3 once. 3 goes into negative 12 a negative 4 times. Now I can go ahead and multiply going across the numerators. That would be a negative 4m, and 1 times 5 would be 5. And that is actually in its simplest form. Now, another way that you might see that written sometimes is a negative 4/5 m. I would say writing it this way is perfectly fine. I just wanted to note that it could also be, and usually when they're doing this in a text, you can see that they can use their typesetting to make it look like the negative 4/5 m. Just in case you need that on testing or on 10 marks. Okay, now we're going to do one other new rule that we have not talked about, and this is when we're multiplying exponents. When the exponents have the same base, so that's n, they're both terms of n, we would add our exponents when we get to multiplication. So first of all, we need to do, can we do any reducing? Because that's always our first, well, first of all, they're both in fractions. And then can we do any reducing? We can't because the numerators have a variable in it and the denominators do not. So we cannot do any reducing. So then we're going to go ahead and we're going to multiply going across. So we have 5 times 1, which would be 5. And then as I just said, multiplying the same base. So it's going to be, they're going to be n terms, but we're going to add the exponents. Make sure you have that in your notes. So 2 plus 3 gives me the exponent of 5. So 5n to the 5th is going to be my numerator. And then we're going to go ahead and we're going to, oh, I missed one of our reducing there. So we're going to do it this way, and then I'll show you the shorter way of reducing. So 10 times 9 is 90. Now, 90 ends in a 0, so I know 5 can go into it evenly. So I can say 5 goes into 5 one time, and 90 divided by 5 is going to be 18. And that one might not have been recognizable to you. So my answer would be n to the 5th over 18. Let's go back and I'm going to do some reducing. So I'm going to start out again with n squared over 10 times 5n cubed over 9. Sorry, I totally overlooked that one. So n has a coefficient of 1, so that's already in its simplest form. But when I look at the next numerator, 5 and the opposite denominator, 10, can be reduced. So 5 goes into 5 once, and 5 goes into 10 twice. This one is much simpler. Now I have the same base, so I'm going to keep that as n. I'm going to add my exponents, so it's n to the 5th, and then 2 times 9 equals 18. So always look for the reducing, otherwise sometimes you miss it and it won't be in its simplest form. So we always have to make sure that our answers are in simplest form. And that was multiplying fractions.